Morning, Captain.
Good morning, everyone. We have four classes designed. So what we are going to do is we start with safety, then later on switch on to cargo work, and of course then lastly meteorology. Because we did something on cargo work yesterday, so to change the scenario, I intend to start with safety topic, then move on to cargo work later on and meteorology. But I'll keep posting as we go along the sessions. This session we will devote to safety, in which we are talking about emergencies, which is also part of your syllabus. So, what we are going to do is have a look at one kind of emergency and what actions to take and your response. Trust you have all got your webcam on for attendance. So, the admin will come back and tell you when you can switch off. Till then, keep your camera on to get the attendance captured.
Sir, good morning.
Good morning. Who is this?
Sir, Shivang Chaturvedi.
Okay, जी, go ahead.
सर एक दो क्वेश्चन थे वो एलएसए की, उसमें मेरे को आंसर मिला नहीं, आपके वो जो पीडीएफ भेजी थी। तो कैन यू टेल मी कि व्हाट आर द रिक्वायरमेंट फॉर द एलएसए फॉर द सर्वाइवल क्राफ्ट इन द ऑयल टैंकर एंड गैस टैंकर?
What is the requirement after that? Shivang,
Yes, sir. Go ahead.
can you repeat? I did not get your correction.
What are the requirements of the survival craft for the oil tankers and gas tankers?
Requirements, okay. What are the requirements? I think it is there. We had talked about it. When you
सर
go through
मैं
the list,
वही कह रहा हूँ कि आपने जो एलएसए का कोड का वो भेजा था, वो एक जर्नलाइज भेजा था।
okay.
ये पर्टिकुलर पूछा है, तो इसके लिए और कुछ भी लिखना पड़ेगा ना, वो क्या लिखेंगे?
Oil tanker and gas tanker. ठीक है, we'll talk about it. Actually, I will request you all to mute yourself because there is a lot of background noise. I think you are also hearing it. There are two devices working very close by, which is creating echo. Keep yourself muted, that will help. Let me try mute all. Okay.
Good morning to all of you.
Good morning.
Good morning.
Good morning,
Good
ma'am.
morning. आप स्विच ऑफ कर लीजिए कैमरा।
ये तो खड़ा हो गया, याद रहेगा तो आदि। So we can begin for today, and that we will cover up as we go along the day, something what candidates are asking also. One type of emergency is fire on board. So this of course has some necessary mandatory actions to be taken and also control of it. can be devastating, of course. It's a real emergency because if it spreads out, then there is hardly any way you can control it unless you got the right approach to it, for which training, etc., drills are necessary, which you are doing also. It is a panic situation also. I have seen during a drill people getting panicky to the extent that even though the doors are marked with O and S, open shut, but in panic I have seen experienced seafarers trying to close doors in the opposite direction, which calls for correct attitude or training. Training is done, but still, because it creates panic, there is liability for people to misread the situation and act adversely. One minute, I want to open the other format. Just give me a minute. One thing is definite when we talk of the emergency of fire, that instead of fighting it, prevention is much better. That is much easier. Prevention of fire is much easier than actually fighting it. So this is what you will plan and prepare and train for. Control the firefighting operation, organize and train fire parties, inspect and service fire detection and extinguishing systems. This is also necessary to inspect and also have it serviced, the detection and extinguishing system. Why do you think this is necessary? Investigate and compliance and compile reports. Why should this also figure in preparation? Because this is going to help you. Investigation and reports are going to help you to finalize and evolve what more is required for a specific vessel, shipboard operations. Reports will tell you if there is certain misgiving, shortcomings, which you can remove by training. Another important aspect is the knowledge of emergency escape routes. Although they are marked that during your drills and training, this should be emphasized upon the knowledge of emergency escape routes, especially one from the engine room, because that is a place from where confusion can arise. Of course, something will come from your training, etc. But this is what is going to coming for on-board training, emergency escape routes, because it will be different for each ship. So this has to be carefully done, and all involved will have to undergo the knowledge for emergency escape routes. Of course, fire means uncontrolled. Controlled fire is okay because that one is being used for day-to-day activity. What concerns us on board is uncontrolled fire, which can harm, cause loss to ship, crew, and also cargo. Air, fuel, and heat. We are well aware the triangle which causes fire to take place. That is the fire triangles, what we have been doing from, let us say, pre-C days. It still holds good, the fire triangle. So either one of them can be compromised with by taking action to control fire. Heat, oxygen, air, which means suffocating the fire itself from air, and fuel source. As I said, this is being done from PC, so you're well aware, but it still holds good and should be mentioned in the answer also. And of course, the terms used will be like this: removal of fuel means starvation of the fire. removal of oxygen is called smothering. Heat, removal of heat is by cooling. And chemical reaction, control of that is also important to stop it. This is how it goes by mixing. Of course, very elementary. Since we are discussing the topic, this is very elementary, but of course should be known since we are doing the topic. Fire is heat and light from rapid combination of oxygen and other materials. The flame which gives the light is composed of glowing particles of burning material and luminous gases. Luminous gases which could be toxic also. Combustible substance should be present. Heat in form of temperature must be high and then enough oxygen to sustain the combustion. Of course, oxidation is a chemical combination of heat with fire with oxygen, which is exothermic, which means gives out heat. When we talk of chemical reaction involved, between different substances, which usually include oxygen and will have a generation of heat and light in form of flame. It will depend on the nature of the reaction, how much and the rate at which the reactants combine to produce heat. These definitions, which are well known, can be still reviewed again. This is important because for a ship, the fire could lead to explosion. This is also important because what it is suggesting is that instead of the fire being completely put off, it may be smoldering, burning sluggishly. Smoldering, which will mean burning sluggishly with smoke. A lot of smoke, but no flame. So instead of having the fire put out completely, it is possible that it may be still smoldering, which is even more dangerous. Again, flammability is the ability of a substance to burn. Simple definition, flammability is the ability of any substance to burn. The ability. Ignition point. The lowest temperature in which a flammable substance must be heated for it to ignite. That is the ignition temperature, ignition point. The lowest temperature where a flammable substance, it has to be flammable of course, it should be heated to that particular temperature for it to ignite. That is the ignition point. Not same as flash point, which is the lowest temperature at which vapors of a substance are available in sufficient quantity to produce momentary flashes when flame is applied. So flash point, ignition point, they are different by definition. Fire point itself, the temperature at which the heat from the combustion of burning vapor is capable of producing sufficient vapor so that the combustion can continue. This is also important, spontaneous ignition temperature, which is the lowest temperature at which the substance will ignite spontaneously without any introduction of flame. Any example of this as carnivore, spontaneous? Well, sulfur is one.
Sulfur.
Yeah, sulfur. Sulfur is one, which is a huge concern for ships which are carrying sulfur because it is liable for spontaneous ignition. Sulfur is a cargo which is identified and is always under careful carriage because of this. I'm sure you've heard of this or
कोल भी
experienced.
सर कोल भी आएगा ना इस कैटेगरी में
Coal for spontaneous.
यस सर
Okay. पर उसके साथ एक चीज एसोसिएटेड है, दैट इज उसका टेम्परेचर 55 डिग्री सेल्सियस वगैरह से ऊपर होना चाहिए and it should have been identified liable to combustion. See, two categories, if you remember, we had discussed it, two categories. One, the coal which produces methane, and another one which is liable for spontaneous combustion.
यस
Two categories, broadly speaking. So that should be clearly mentioned, and accordingly you will carry it. When the declaration has been made, precautions will be different for each one of them, whether it is for methane or spontaneous. Obviously, if methane is produced, then you are going to have an issue regarding production of carbon monoxide also, which is an indication that there is a possibility that it might ignite. Static electricity, something which we experience at land also. Two dissimilar materials coming in contact with difference in potential charges can ignite flammable vapors just by rubbing, which we experience every day also. Even here at land, when you have wearing shirts being made of a material which can give out static electricity, this is okay as far as living on land is concerned, but this is a huge concern if you are working on tankers. If static electricity is generated, then it can ignite the flammable vapors which may be present for a tanker. That is going to cause a concern. LEL, lower explosive limit. This is the minimum concentration of a particular combustible gas required to support combustion. Below this level, the mixture is lean or it cannot ignite. That is a LEL, lower explosive limit. On the other hand, you have what is upper explosive limit, the maximum concentration. LEL is the minimum concentration of the vapor, and upper UEL, upper explosive, is the maximum concentration. Above this level, mixture is ready to burn. I will use the word ready to burn, although terminology says very rich to burn, because it has already got a huge concentration of gas or vapor. Since you have two limits, LEL and UEL, the range, flammable range, is in between these two. This is explaining it. UEL line, LEL line. Above this is too rich or very ready for combustion. Below this is lean, can be prevented. Hazardous material identified as hazardous material will also have these two limits. Obviously, concern will be with upper explosive limit. Beyond this, the whole thing is very rich to burn or ready to burn. So you must have this correct information in hand. What are these limits so that you can monitor by various equipment, instruments, you can monitor the content and see whether it is coming UEL, because that is going to cause a concern for fire. As we can see, between these two, LEL and UEL, is what we have the flammable range. Flammable range. Another term used is flashover. This is in an enclosed compartment. Hot air will always rise on top towards the ceiling, and this will cause a hot layer to be formed. As fire proceeds, this layer increases in depth. Temperature keeps increasing. When all the oxygen is used, the fire dies down. But the atmosphere still has some leftover of unburned vapors at ignition temperature. Now, if the fresh air is introduced by any chance, the unburned vapors will burst into flame. This is called flashover. You could have a phenomena called boil over. This is if water falls on oil at a temperature close to or higher than the water boiling temperature, 100 degrees Celsius, then the water gets converted to steam straight away, rises with the particles of oil like a cloud. This can get ignited immediately, and the occurrence can of course spread a fire, which is boil over. This is particularly of importance when you're working on tankers, and then you can have an issue. You want hot oil, and on which some water can fall. Then you will have boil over, because when the water falls on the heated oil near 100 degrees Celsius, it will straight away convert to steam, which will rise. Steam will rise, but it will carry with it particles of oil. Now, that is a very dangerous situation, because these particles of oil being carried into the steam can get ignited. The phenomena is called boil over. Another term used in pyrolysis, solid fuel. To burn, it must change into vapor state. This reaction or chemical action is called pyrolysis. Chemical decomposition due to application of heat. The decomposition composition creates fuel vapor, which when mixed with oxygen can produce a fire. The phenomena is called pyrolysis. This is the construction or formation of pyrolysis. Another very important term used is BLEAP. Boiling liquid, expanding vapor explosion. Boiling liquid, expanding vapor explosion. This one. I'm sure people who have worked on tankers are aware and have come across this term. We are looking at a closed container which contains flammable gases in liquid state. So some of this liquid inside will get vaporized. This will increase the pressure and that can lead to explosion, which is called boiling liquid expanding vapor explosion. BLEVE, BLEVE. We are looking at straight away liquefied gas vessel. This is happening. External fire is playing on the liquefied gas vessel. Liquid boils, enabling a part of the vessel to heat up and rupture. That is the explosion part. Because of the explosion and rupture, the liquid escapes from the vessel, boiling, creating an expanding vapor cloud with huge amount of energy. Particularly dangerous and identified for liquefied gas vessels or liquefied gas carriers. Remember the term BLEVE, BLEVE, boiling liquid expanding vapor explosion. Hazards identified as bar diagram, mostly from machinery spaces, up to maybe about nearly 50%. Accommodation, cargo area, external fire sources. Also emphasized, but yes, it is always there. Unknown sources, cargo pump room. This is also a very hazardous area, cargo pump room identified. On board ship, some general causes identified on board ships which concerns us. Some general causes identified are going like this. One is smoking. In fact, there is a lot of emphasis on this because this is one of the most readily identified cause of fire on board. not the smoking itself, but the disposal of unburned burning cigarette that is making it dangerous. So smoking is a factor that will happen only to people around him or maybe himself. But when we talk of disposal of that, the butt, which we say, is going to have a harmful effect if it is careless disposal. And mostly it is caused because designated areas are avoided or not used for this, and you have, because in the designated areas you will have disposable ashtrays also, but outside it you may not have it. So although it sounds very, you know, childish, but this is a basic cause. It has been identified as a huge cause for fire on board. Approved ashtrays in the designated areas, warning signs. Warning signs in those areas where smoking is strictly prohibited. Although it seems unimportant, but it still has importance because so many accidents are taking place even in this modern world when everybody is aware. Next cause identified is electrical short circuit. Heaters unguarded. This is very important. Many accidents have taken place. Heaters left on while the cabin is not in use. Portable heaters, overriding fuses. Overriding means fuses are supposed to break the circuit, but overriding fuses have been used, so this can lead to electrical short circuit or electrical fire. Faulty fittings is also there, of course. Faulty fittings, cut wires, chapped wires, no plugs. No plugs means the wires are inserted straight into the socket without plugs. You are actually calling for trouble. Prevention is by inspection of the accommodation spaces and taking care that this is not done. You will have your rounds. You are supposed to take rounds, safety rounds. As a chief officer, if you are the safety officer, you are supposed to take rounds. So, with those rounds, these things have to be clearly identified. Short circuits is definitely an issue. Electrical short circuit. This is going to lead to a fire. Not necessarily, maybe I've stressed it too much, but it could lead to a fire, a short circuit. Overloaded circuits, because too much load has been put in a source. This can result in high current flow through the wires and overloading the circuit. By overloading the circuit, the wire itself can start burning. If there is water present, then you can have leakage current. This is when you have unprotected wire coming in contact with water, because the wire has not been properly engulfed in any sheathing. you will be surprised. This is also identified as a major hazardous area because this is left unattended. The laundry rooms, especially when you have heaters for drying and the clothing has been put directly over it or maybe just very close to it. If it goes and attaches itself to the heater radiators, then it can catch fire. This is another thing which you need to examine or insist upon when you're taking your rounds for safety. A very common problem because of paucity of time, people do have the tendency to get the clothes dried up as soon as possible. So they may hang it over the heaters or very close to it so that they dry up fast, which can lead to fire. Air filters are present in the dryers, the laundry room. This can also get overheated and ignite. This is very common. I'm very sure you will identify it quite readily. This is a huge hazard. Again, because of the temperature of the engine room, the tendency is to dry up clothes by hanging over the railings in the engine room. And this can be a fire hazard, obviously. Many accidents have taken place. Still, people do not refrain from this. It is not supposed to be like this. The railings are only prevention of falling and also guide for climbing up and going down. This is not a place where you can do drying of clothes, of course, you are aware. I'm saying this has been identified, actually identified, as a very potent source of fire. Drying of boiler suits or other clothes in engine room. When we talk of spontaneous combustion, you have examples like oil rags. This is also something which is used extensively and left unattended. Then oil rags is a source of spontaneous combustion. Especially if the oil rags are thin. If they are thin, the oil will evaporate very rapidly. This is an exothermic reaction and this can accelerate as the temperature of the rag increases. The evaporation of oil from thin rags. Paint stores. This is also area of concern. In fact, you have detectors and of course you will have detectors, but you also have some ships use detectors linked with the fire main. So if the detector senses a fire, the fire means automatically come out. Anybody worked on a ship like this in a paint room? Right. Okay. Take a small break. We come back meet at 10:15. So paint stores are an issue for which I said there could be arrangement when the detector is energized due to presence of heat or smoke. There are some requirements, some class requirements to say that immediately the fire sprinkler should come on. Once the detector is activated, fire sprinkler should come on in the paint store. But this is not a requirement for all ships. This is only depending on class. However, there have been cases, especially in Chinese PSC, who want this one necessarily. Storerooms with the wall drums, etc., are also an issue. They should have an appropriate detector system. High fire risk, of course. And of course, the whole thing will be correlated or be determined by the FSS code, which is a code applied to SOLAS for fire system. For fire safety systems, you have this code which is applicable for fire protection and firefighting. This one. So I would recommend you go through it necessary, because you cannot memorize everything, but you should be aware of the code itself and how different types of extinguishing systems can be used, like fixed tech foam system, fixed emergency fire pumps, and of course inert gas system. Of course, nothing in firefighting system can be completed without the mention of international shore connection. One minute. Let me locate a diagram for it. That will make it better. Yeah, this one is better. So this is something you may have read it also, but it's still important because it can be asked anytime, even in the oral examination. Do you have a drawing of this? You can make one. As you can see, this is coming straight from the FSS code, this one. Standard dimensions for international shore connection. Outside dia 178, inside dia 64, bold circle dia 132, slots and flanges, 4 holes 19 mm, equidistant of course. Flange thickness 14.5 mm minimum. Bolts and nuts 4 each of 16 mm dia. Length 50 mm. And of course, this is how it looks. The flange 19 mm, inner dia 64 mm, outer dia 178 mm. Flange to flange 132 mm. Various nozzles. Attachment to the fire line or the fire main to be maintained of course. This is a block diagram for the fire mains organized, including connections from main fire pump and emergency fire pump. You can have isolating walls to separate it out. The main deck from the accommodation and engine room you can separate out using a deck isolator wall. Basic diagram for fire mains. will agree a question can be floated around with reference to Chapter 2, SOLAS, FSS code, explained with diagram, the arrangement for firefighting system on board using seawater. Are you interested to draw this, or have you already drawn it, or you have got an access to it? Then we can skip over. Firefighting medium, seawater, the most commonly used and readily available. The main thing is that water has property to reduce heat or by absorbing. Cooling of the flame temperature when water passes through combustion zone absorbs heat through evaporation. Since water is passing through and evaporating, it will absorb the heat. So that is one way to cool the area itself and get it below ambient. As soon as you got the cooling of the flame going, this will cut down the amount of heat being released by fire, and therefore it will not go back to the fuel surface. How can seawater be effective for fighting fire? So another advantage with the water firefighting is that when it evaporates, it turns into steam. The steam, which is in the vicinity of the chemical reaction, displaces the air. That is suffocation for the fire because it is displacing the air which is supposed to supply oxygen for combustion. So smothering can now take place even though nothing has been created. Just the water has been used to create steam by a natural reaction, water evaporating, creating steam. The steam in the vicinity of the fire is going to displace the air which was supposed to supply oxygen for combustion. This can result in smothering. Some examples of fixed water sprinkling systems could be water spray, water sprinkler, and water mist system. Hoses, nozzles, fire hydrants, and water monitors are used for delivery of water, of course. So this one, I'm sure you've done on your, if you are got the access, no problem. But I have seen this question somewhere to draw a block diagram explaining the use of seawater to fight fire on ships. It may be differently worded. You're working on a cargo vessel or submarine cross tonnage. Draw a diagram to explain the use of seawater for fighting fire on board. These are the different hoses and nozzles being used. Shore connection we have just now seen. Hypermesh system. This one. You have worked with this one on board, Hypermesh. Where do you normally find it?
Engine room.
Engine room, okay. More so near generators. This is the principle. Uniform microflows out of nozzles under pressure, which could be 40 to 100 kgf per centimeter square, kilogram force per centimeter square. The working pressure, anything between 40 to 100. This is making use of water in form of fine particles. Because the water is being used as fine particles, it is providing a mist. That is why it is called hypermesh system, like a mist. This improves the fire extinguishing effect. So some fires like oil fires, electric fires, etc., which were difficult to extinguish with water or could cause electric short circuits, etc., this thing can be used. The system hypermesh could be used for oil fires. Actually speaking, oil fires you should be fighting with which type of extinguishing system? Oil fire. Foam type. Electric fire by CO2 system. You can see how small the particles are, 50 to 200 micrometer, which is very small. That is why it provides a mist. The visibility of this water being spread is like a mist. It is called hypermesh system for this reason, because the particles are very, very small, minuscule. This is mandatory in passenger ships for GT cross tonnage of greater than 500, cargo ships with GT greater than 2000, and also for machinery spaces with volume greater than 500 meter cube with cargo pump rooms. So something was being interacted upon. This can be also one system to be used for oil tankers and gas carriers. Hypermesh. The actual extinguishing process is based on three mechanisms: cooling of the flames, one, reduction of oxygen by displacement of the air, due to the water vapor or steam production. And diminution of radiating heat, because diminution means reduction of the radiating heat. Let me try and keep this in view. So when we talk of the MSc circular for fixed firefighting using water, then this is the guideline. We have come across the MSc circular. 1 minute. This circular. Oh, just 1 minute. This circular IMO MSc circular 913. This is talking of fire extinguishing in machinery spaces with volumes greater than 500 meter cube. So when we talk of this circular, this is how it appears. I was able to trace it just for a small interaction. This is the circular we are talking about. MSC slash circular 913. It will of course first start with some definitions, etc. Fixed water-based local application. This is again coming from SOLAS regulation, chapter 2. The identification was that you have this fixed water-based local application without necessity of engine shutdown, evacuation of people, and shutting down of post ventilation plants, or sealing of the space itself. This was the recognition why this was designed to have an alternative method so that nothing can be disturbed. Means no need for evacuation, no need for engine shutdown, no need for forced ventilation to be closed. So it does start with the definitions: fire suppression, water-based extinguishing medium, freshwater or seawater, with or without additives to enhance fire extinguishing capability. But categorically, water-based, freshwater or seawater. The system should be capable of manual release. Activation of the system should not result in loss of electrical power. No, should be capable of fire suppression. The component itself of the system should be able to withstand temperatures, vibrations, humidity, shock, impact. It should be designed like that. It is also recognized that the system itself should be designed to withstand elevated temperatures during fire. The water supply for the local application which we are using for hypermist should be fed from the supply to the water-based main system, providing adequate water quantity. So the fire mains itself should be able to supply water to the hypermist also. Operating controls to be on easily accessible positions. Pressure source components should be located outside the protected area. This is very important. A means for testing operation of the system should be done or should be provided. This I think you might have witnessed it, although you're not in the engine room, but you might have witnessed it, the trying out of the system itself, which could be a requirement for a PSC inspection also, test the operation. So this is also required by the guideline itself. There should be a system of means for testing operation, which I have, if I can recall, some PSC inspectors are prone to having this one done. They want to witness it. No need to actually mention this, but spare parts and accessories should be available as recommended by manufacturer for any parts to be changed. This is important. Nozzles and piping should not prevent access to engine or machinery for routine maintenance. That is why the layout of the system should be not to prevent access. Then even a test method is given for fixed fire bonding. There is appendix in the circular which tells you how to do the test. We are not going to go into that, but just for information that there is something mentioned in appendix for the test method for fixed water based system. When you're trying to evaluate the fire extinguishing capability, then this will take into part maximum spacing between the nozzles, maximum distance between nozzles, need for nozzles to be positioned. This will depend on the construction of the vessel or the size of the engine room. These are some parameters to be followed for spray nozzle, angle 120 degree to 125, full cone type or wide angle spray. Pressures 8 bars or 8.5 bars. Not to be memorized. It is only for our reference that there is some mention about this one also. Locations are also described, how to locate them, then some test results and its interpretation. Interestingly, each fuel oil spray should be ignited and allowed to burn for more than 15 seconds prior to system operation. 15 seconds at least, this should burn. Then only you deploy the system to test it out. And some observations to be recorded, documented like this: start, stop, activated, extinguished, and then the test report. That was regarding Hypermist. Process absorbs much energy, lowering the temperature of the fire because water expands about 1700 times, taking the air away from the fire. The air is displaced by the steam. so suffocating the fire. Water consumption 6 to 10 times lower than the traditional sprinkler because it is only a mist. So creating a mist, of course, is going to involve water, but consumption, but it will be lesser than the traditional sprinkler, which is using water sprinkler itself, not the mist. So consumption will be lower than the traditional sprinkler. This is also very interesting and important. Should be able to be activated automatically by two different types of detectors, flame or smoke. Either flame or smoke or both. Whichever is being deployed on board that vessel, when activated, it should get automatically charged. If you have witnessed it, this is how it is done actually on ships. In the engine room, you have a detector overhead, so you activate the detector and the system comes on. Then it is proved that the system is working correctly. Suction from freshwater tank provided to supply high pressure water to the sprinkler system. Isolating valves can be used to isolate areas which are not required to be supplied with water. This should be kept at constant stage of readiness, of course. Water mist particles, diameter of the mist particles range from 50 to 200 micrometers. This provides efficiency. Of course, the distance between any two nozzles is critical, as this is what will decide the area covered. But it should be designed in such a way so that no space is left unsprayed in the fire affected area. This is how the design of the spacing of the nozzle should be done. This is how it looks in operation. There should be both possibilities, an automatic start and manual start. Audible visual alarm should be there when activated. Of course, this can be checked on regular basis that water levels are maintained in the freshwater tank which is supplying the water to the hypermist. Of course, this can be also recorded maybe on a daily basis. It has to be recorded because this will ensure firefighting capability is in readiness. Hypermist will have following effects: cooling effect, oxygen replacement effect, and the shut-off effect. Do you recognize this? Must have visited on board also the CO2 room. Again, a fixed firefighting system. This is simply a system which will release CO2 in bulk. Protected space could be engine room, cargo hold, purifier room, pump room, etc. Any of these spaces under fire, the smoldering action of the CO2 could be used. So this is not only suffocating the fire to extinguish it, but also preventing spread of fire. Several CO2 cylinders located, and this is called the CO2 room, which we are aware. CO2 room. These bottles contain CO2 in liquid state. CO2 from these bottles is directed to a common manifold via nozzles when it is to be released. To prevent accidental flooding, CO2 system is manually released from a release cabinet which is located outside the protected space. Obviously, it cannot be located inside the cargo hold, engine room or purifier room, etc. It is located outside the cabinet for manual release. I'm sure you have visited this, you have gone on into it. You will be involved, of course, as chief officer, because if there is fire in the cargo hold, for example, you will need to know the line and what valves to close and shut so that CO2 can be released to cargo holds. So the CO2 bottles will contain CO2 in liquid state. Pressure of 56 bar at 20 degrees Celsius. But if you say that the CO2 temperature is like 25 and 30 degrees, then the pressures will be 64 and 71 bars. So keep the temperature of the CO2 bottle low for limiting pressure inside the bottle. This can be done from the main bottle, activated from the main bottle inside a CO2 release cabinet, means using a CO2 release cabinet. As soon as the release cabinet door is opened, a micro switch is activated. This micro switch will ensure activation of CO2 warning alarms and ventilation shutdown. They are all having a nexus, all interconnected, integrated. So as soon as the release cabinet door is opened, activation of CO2 warning alarms and ventilation shutdown will start. This is integrated. As you must be well aware, warning alarms is very different from the general alarm. In fact, Training for this also should be carried out so that people, when hearing this CO2 release alarm, will recognize this is not a general alarm, this is for the CO2 release, and then they will take action to evacuate. This should be done in the training sessions also. Engine room evacuation is essential before you flood for CO2. This will carry an alarm which should be clearly audible and recognized by the crew inside the engine room that this is not the general alarm, this is for the CO2 release, calling for evacuation. Two pilot bottles are used, which is again containing CO2 gas. Two pilot bottles. Release cabinet with two pilot bottles. It is important to note that there is a time delay unit for a simple reason, because if this unit is opened, there will be an alarm. The time delay unit provides time for people to evacuate and be carefully warned. This one is okay. I don't think there should be any trouble understanding this one. have been using this on mode, right? So you can close this session. We meet again at the design schedule time, I think 14:30, and we will pick up another topic. If you have any query or question, you can raise it. Well, you can respond to the feedback chat box. That will take care for time being, and we'll meet again in the next design class.
Hello, beta. Good afternoon, everyone.
Good afternoon, sir.
Good morning, sir.
Good morning. Good morning. Beta, the recording is on now. So we are going to continue with our topic for today. Today, I'm going to cover up with you a topic which is called as stars suitable for sight. So let me first explain to you what is the meaning of this topic. Now, in this, we actually try to find out that if we are taking a star sight, we take a star sight during twilight time. Let us say in the evening you decide to take a star sight. There are so many stars in the sky, and if we want to use a star for a meridian passage observation or for a X meridian observation. Now for a Marpas observation, the star has to cross our meridian, and for a X meridian observation, it should be close to our meridian. How to identify or find out if we have a star which can be used for these sites or not? So this is our today's topic. So we will see how to find out the stars which can be used for a Marpas observation or for a X meridian observation. So I will first take you through some basic concepts in the presentation. These are the concepts of twilight and stellar magnitude. And once those are done, then I will take you to a video where we will solve questions based on this. So that is the plan for today. So shall we start with the presentation?
सर
बोलो बेटा.
सर ग्रुप में सर एक क्वेश्चन भेजा है वो आप देखेंगे सर एक बार.
ओके. अब बेटा पहले ये टॉपिक कंटिन्यू कर लें, फिर उसके बाद क्वेश्चन पिकअप करते हैं.
जैसे भी सर जैसे.
राइट. So let's go into the presentation and we first see some basic concepts, twilight and stellar magnitude. In this presentation, we are going to discuss the concept and topic of stars suitable for observation. Go ahead, beta.
सर सर ये रिकॉर्डिंग पे डाल देंगे प्लीज.
Okay. Hold on, beta. I forgot.
Okay, sir. How we start?
Recording is started, beta. Recording started. Okay, let's continue. Now, this particular method, star suitable for observation, is used to ascertain or find out which stars will be suitable at the time of twilight for a particular observer if he wants to use a specific method of sight or a specific method of observation like meridian passage, Marpas or latitude by meridian altitude, or X meridian. So basically this means that if a observer wants to take a star sight at the time of twilight, twilight is the only time when a star sight can be taken. So he wants to take a star sight, but he wants to use a specific method. He wants to use a particular star for meridian passage or for a X meridian sight. Now, how to find out of so many stars which are visible to us in the sky, which of them are suitable for the Marpas observation or for the X meridian observation. That is the meaning of the topic, stars suitable for observation. Now, before we go into this topic, we need to understand a few basic concepts to familiarize us with the method and procedure which we use to determine which stars are suitable for meridian passage or X meridian. Now we understand that only those stars will be suitable for a Marpas observation which cross the observer's meridian during the twilight time. Meridian passage sight is taken at the time of the celestial body crossing the observer's meridian. And if we want to use a particular star for X meridian sight, we are aware that that particular star should be within the X meridian limit. So we need to check the X meridian limit for the observer for that particular body, and we need to make sure that the particular star is within that X meridian limit to be suitable for a X meridian observation. Now, the basic topics which we need to understand before we jump into this topic are number one, the concept of stellar magnitude, and number two, the concept of twilight. So we are going to understand these concepts one by one. Let's first go into the concept of stellar magnitude. Stellar magnitude is a scale used for specifying the apparent brightness of a star as observed from the Earth. The magnitude number decreases as the apparent brightness of a star increases. You can see this diagram showing some specific celestial objects, celestial bodies, and also their stellar magnitude. You can see the brightest object in the sky which we have is the sun, and it has a stellar magnitude of -26.8. Now, as I told you earlier, the magnitude number decreases as the apparent brightness increases. So the celestial body having maximum brightness is the sun, and it has the minimum magnitude number. The magnitude number of the sun is -26.8. Now, after the sun, we have the moon, the second most bright body in the sky, and the stellar magnitude of the moon is -12.5. Then after the moon, we have the planet Venus. When it is at its brightest, it has a stellar magnitude of -4.4. Then we have star Sirius having a stellar magnitude of -1.5. Then Alpha Centauri, the nearest star to us after the sun, having a stellar magnitude of 0.0. Then Betelgeuse 0.8, Polaris 2.5. Now, the limit of the naked eye is stellar magnitude 6.0. These stars with magnitude 6.0, very, very faint stars, barely visible to the naked eye, are the 6.0 magnitude star. They are also called as sixth magnitude star. The brightest of the stars which we have, like Betelgeuse, Alpha Centauri, Sirius, they are called as the first magnitude star. So faint stars, barely visible to the naked eye, sixth magnitude star, and the brightest of the stars coming under the first magnitude stars. Now, if you go a little more further, if you use a binocular to observe the sky, you would be able to see the stars having a stellar magnitude up to 10. If you have a 1 meter telescope, it can help you to see the stars up to a stellar magnitude of 19. Then another important telescope which we have, Hale telescope, can see the objects having a stellar magnitude of 27, and the most powerful telescope which we have, the Hubble telescope and the Keck telescope, they can help you to see the stars, celestial object with a stellar magnitude number 30. So a diagram giving us a comparison of the brightness as well as the stellar magnitude of different celestial bodies. Now, a first magnitude star is 100 times brighter than a sixth magnitude star. We can also calculate, if we have two celestial bodies, their stellar magnitude known to us, we can calculate how many times a particular celestial body appears brighter than the other celestial body. We have a formula which can be used to calculate the relative brightness, and that formula is relative brightness of a body compared to another celestial body is equal to 2.51 raised to power x. Now, what is x in this formula? X is the difference between the magnitudes of two bodies which are being compared. So if you are given two celestial bodies, their stellar magnitudes are known. You can find out the difference between their stellar magnitudes. 2.51 raised to power that difference gives you how many times a particular body is brighter than the other. Now we have seen the stellar magnitude of the stars.
stellar magnitude का दिया हुआ होता है?
We know that
Almanac में दिया होता है?
faintest of the stars are of magnitude 6.0 and the brightest of the stars are magnitude 1 star. Now these stars are categorized basis their brightness. We have put them into categories. Go ahead, beta. What's your doubt?
सर ये स्टेलर मैग्नीट्यूड ये एल्मेनेक में दिया हुआ होता है या कैसे पता कैसे करते हैं?
It is given in the almanac, beta.
सर किधर?
Okay. Stellar magnitude of planets is given on the daily page. So you can see on a daily basis what is the stellar magnitude of all the 4 planets. And stellar magnitude of stars is given on a table on page 268. Just check it.
हाँ, इसका तो दिया हुआ है, ठीक है, यहाँ पे तो 268. सर जो डेली बेसिस पे आप प्लैनेट का बोल रहे हैं,
राइट,
इसमें तो GHA डेक्लिनेशन जैसे किसी का भी और नीचे मरपास दे रखा है और साथ में SHA दे रखा है.
राइट.
इसमें कहाँ दे रखा है ये स्टेलर प्लैनेट?
जहाँ प्लैनेट का नाम लिखा है ना, उसके आगे एक नंबर लिखा हुआ है.
हाँ,
नाम लिखा है उसके आगे
ओके
-3.9 ऐसे लिखा हुआ है, +1.3.
ठीक है, ठीक है.
मिल गया बेटा?
हाँ सर, हाँ.
ओके, वेरी गुड. मैं ये जो पेज 268 वाला टेबल है ये आपको अभी डिटेल में बताता हूँ. गो अहेड बेटा.
सर जो आपने स्लाइड में सन का मैग्नीट्यूड बताया उधर 26.7 है सर.
एक मिनट बेटा. So it is 26.7.
Correct sir.
Is it given somewhere?
सर यही पढ़ा है बुक्स में सर.
Okay, all right. हो सकता है बेटा. There could be a bit of change from the sources. It is perfectly fine. All right, could be 26.7 also. Okay, और बेटा और कोई डाउट अभी तक? Okay, all right. So let us go into categories of stars now. We have seen the stellar magnitude.
Yes, sir.
Now we have seen the stellar magnitude of the stars. We know that the faintest of the stars are of magnitude 6.0 and the brightest of the stars are magnitude 1 star. Now these stars are categorized basis their brightness. We have put them into categories. Now what are these categories? All the stars having their magnitude less than or equal to 1.0. That also includes the star in the negative stellar magnitude range. So all the stars having magnitude less than or equal to 1.0 are called as first magnitude stars. This is a group of the brightest possible stars in the sky, and they are the most preferred stars for the purpose of sight taking or for the purpose of observation. We always prefer to have a first magnitude star for our sight taking purpose. They are the easiest to spot in the sky, being the brightest. Now stars having magnitude greater than 1.0 and less than equal to 2.0 are called as second magnitude stars. In case you are not able to find a suitable first magnitude star for the purpose of sight taking, you can also choose and pick up a second magnitude star. They are also bright enough to be used easily for the conveniently for the observation. Now, after this, stars having magnitude greater than 2.0 and less than equal to 3.0, they fall under the category of third magnitude stars, and so on. 3.0 stars having magnitude greater than 3.0, less than equal to 4.0, fourth magnitude. Stars having their stellar magnitude greater than 4.0, less than equal to 5.0, fifth magnitude, and so on. Now, why are these categories important? Because in the questions, they sometimes ask us to find out the first and second magnitude stars which are suitable for a particular observation. So in that case, we check their magnitudes from the almanac, and whichever magnitudes fall under our required category, we pick up those stars and write them as our answer. So any doubt in this, beta? Okay, can you tell me star having a magnitude of 1.0, it will fall in which category?
1, sir.
1, sir.
Very good. It will be under first magnitude star. And star having a magnitude of 2.1.
Sir,
third magnitude.
Very good. It will be falling under the category of third magnitude. Great. So this was about the stellar magnitude. Let's now proceed ahead. Now going further, we need to be familiar with the stars information table given on page number 268 of the 1992 almanac. Let's have a look at that table. We have the left-hand side page of the table. This is page number 268 of the almanac. And now you can see on the right side is the right-hand side page of the stars table. That is page number 269. Now this table gives us the required information about the stars. The first column which you see gives us the magnitude number of each of the star. The second column gives us the name and number of the star. After this, you see the next column of the table gives us the SHA and declination of the stars from January to June. For the first 6 months of the year, the SHA and declination is given on the left-hand side page. You have the SHA given first, later on followed by the declination of the star. Now we are aware that the SHA and declination of the star does not change much. There is a very minute change in the SHA and declination of the stars. They can be practically assumed to be fixed bodies on the celestial sphere. So that's why you see in this particular table, the degree values of SHA is mentioned in the beginning, and the minutes are mentioned under each and every month. Now the change in SHA, what happens is happening only in the minutes. The degrees usually do not change. So under every respective column of the month, you see the minutes value is given. So you pick up the degree value from the first column, and then you pick up the minutes value from whichever month you require the value for. The same is done with the declination. You see the degree value is given initially in the first column, followed by the minutes value for each and every month. And you can see here that the value changes by a certain minutes every month. The change is very, very gradual and slow and not very significant. Now on the right side of the page, we have the SHA and declination of the stars given from July to December. So the right side page gives us the required information for the last 6 months of the year, July to December. You have the SHA and then followed by the declination. Again, the same format is used. Degrees are given in the beginning and number of minutes are shown under each and every month. Now the stars are listed in this table as per increasing order of their SHA, sidereal hour angle. You can see the stars starting in the table from 000 SHA going up to 360 degree SHA. So the first stars which you see is 5 degree SHA, the next one 13, 14, 15 and so on. So if you want to identify or pick up a star from its SHA value, this table is very convenient to use. You can enter into the SHA value column, and whichever SHA value you require, you can identify that particular star from this table. Now the left side page of the table gives us the Latin names of the stars. The names which are mentioned here in this particular column are the Latin names of the stars, along with the SHA and declination from January to June. Whereas the right side page which we see gives us the English names of the same stars. And also, as we discussed just now, it gives us the SHA and declination of the star from the month of July to the month of December. So important thing to remember here is whether you go to a particular star on the left hand side page or you go to that particular star on the right hand side page, it is the same star mentioned. Only thing is the names given on the left side page are Latin names and the names given on the right hand side page are English names. To give you an example, pay your attention to the number 2 star which we have on our list. On the left hand side page, you see the number 2 star which we have is Alpha Pegasi. Whereas if you go to the right hand side page of the table, the same star is mentioned as Markab. So on the left hand side, Alpha Pegasi, on the right hand side, Markab represents the same star. Alpha Pegasi is its Latin name and Markab is its English names. Now, as far as our exams are concerned, we always use the English names of the star. So whenever you are required to identify and list down the stars, you will be picking up the English names, irrespective of the month of the year, whether it is January or June or July or December. any month of the year, you will be picking up the names in English. That means the name from the right-hand side page of the table. So if you are picking up the second star, even for the month of January, the star will be named as Markib and not as Alpha Pegasi.
सर जो ये नंबर लिखे हैं 57, 56, 55 ये क्या है सर?
बेटा ये जो stars हैं, they are given on the daily page of the almanac also. But daily page we do not have much space, so they have just picked up the selected bright stars. So जिनके आगे आपको नंबर दिखाई दे रहा है, these stars are present on the daily pages also, and इनका SHA declination आप daily page से भी दे सकते हो.
ठीक है सर.
ओके. और कोई डाउट बेटा अभी तक?
सर ये जस्ट आस्किंग, ये सारे नाम सर अलग है ना सर? अल्फा, बीटा, गामा, ये सब स्टार अलग अलग है ना, क्योंकि नाम सबके सेम ही है.
लेफ्ट साइड में देख रहे हो बेटा?
सर राइट साइड में भी लाइक जैसे नीचे से एक लिखा है 2.8 मैग्नीट्यूड बीटा स्कॉर्पी, और एक 3.0 में सर एक पाया स्कॉर्पी करके भी है, मतलब सेम नेम ना?
राइट बेटा, दैट्स राइट. मैनी अ टाइम बेटा जब स्टार्स को नाम दिया जाता है तो क्या होता है कि दे आर आइडेंटिफाइड एज पर द कॉन्फ़िगरेशन विच दे आर ए पार्ट ऑफ. सो वो कॉन्फ़िगरेशन में ही उनको नाम दे दिया जाता है, अल्फा, बीटा, गामा, डेल्टा एंड सो ऑन. So that's why you see the same name being repeated with a different alphabet in the beginning, but they all represent different stars.
Okay sir.
Okay.
सर ये नंबर क्या लिखा है? नेम एंड नंबर. नंबर क्या सर स्टार के आगे?
बेटा इनमें से कुछ एक स्टार्स डेली पेज पे भी दिए हुए हैं. सो जो डेली पेज पे दिए हैं, टोटल 57 स्टार्स आर गिवन, उनको यहाँ पे भी नंबर दिया गया है. दे आर अवेलेबल ऑन द डेली पेज ऑल्सो ऑन दिस पर्टिकुलर नंबर. अगर आप कोई भी डेट पेज खोल के देखो तो आपको ये स्टार वहाँ डेली पेज में भी मिल जाएगा.
ओके सर, ओके, थैंक यू.
ओके. और बेटा और कोई डाउट अभी तक?
और सर वो डेट शीट सर आप ही बना लेना, वो हमसे तो हो नहीं रही सर ग्रुप में.
नहीं बन रही बेटा?
सर वो सबके अपने थोड़े बहुत घर के काम चल रहे हैं सर. तो
ठीक है बेटा, ठीक है. I'll make it and I'll share with you.
सर वो हॉलीडेज कौन कौन से रहेंगे सर नवंबर में, मतलब गेस्ट डेट कौन से रहेंगे?
बेटा एक ही हॉलीडे है, दिवाली की.
ओके सर.
ओके.
वो सर चिल्ड्रन डे का भी उसको चाहिए सर.
चिल्ड्रन डे तो 14th को है ना?
आ जाएगा
बिल्कुल बेटा, चिल्ड्रन डे इज हॉलीडे. और बोलो.
खत्म हो जाएगा सर, ये कोर्स खत्म हो जाएगा तब तक तो पाठक जी.
So all right. Okay, so shall we go ahead?
Yes sir.
Okay.
पॉसिबल हो दिवाली के नेक्स्ट डे का भी रख देना सर हॉलीडे ना, अब पॉसिबल है तो.
दिवाली से नेक्स्ट डे बेटा?
सर आप अपने हिसाब से
दिवाली वाले दिन दिवाली मनाते रहेंगे ना सर?
ना बेटा, नेक्स्ट डे पॉसिबल नहीं होगा. नेक्स्ट डे मुश्किल हो जाएगा.
चलो ठीक है सर.
सर आप बना लेना सर अपने हिसाब से, बिकॉज
I'll prepare बेटा.
6 तारीख को भी है.
मैं आज ही आपको बना के दे दूंगा.
शादियां भी है सर बीच में, तो वो भी इशू है.
नो प्रॉब्लम बेटा, मैं बना के भेज दूंगा.
ठीक है सर.
Okay, let's proceed ahead now. Let's now understand the concept of twilight. Now, twilight is the light received from the sun when the sun is below our horizon. Now, we receive the light from the sun when it is above our horizon, and we call that light as sunlight. But we also receive some light when the sun is below our horizon and close to it, and that is the light which we call as twilight. This happens before sunrise in the morning and after sunset in the evening. So as you can see in this diagram, the right side of the diagram represents the sunrise, and before sunrise for this particular period, the dark blue color sector which is marked here on the right side of the diagram represents the period when we get the twilight. And when the sun goes on the western horizon, you can see in the diagram, the sun going in the western horizon sets at this particular instant, and after setting we keep on receiving the light which is called as twilight when the sun is in this dark blue color sector. So in this particular sector we receive the twilight in the evening. Now even though the sun is below our horizon, it still illuminates the upper layers of the atmosphere. Now this happens because of the refraction and scattering principle. The light undergoes refraction in the atmosphere and it gets scattered in various directions, because of which we are able to see the light even after the sun has set or the sun has gone below our horizon. Now in the evening, when the sun sets, till the time sun is there in the sky, we receive the sunlight. Now after the sun has set, we do not have any sunlight. What we receive now is the twilight. The twilight is available to us till the time the sun goes 18 degrees below our horizon. So you can consider this 18 degrees as a negative altitude of the sun. Till the time the sun is within 18 degrees of our horizon, we keep on receiving this twilight, and after the sun crosses this 18 degrees belt, after that there is total darkness and we do not receive any light from the sun. So in the evening time, the twilight commences at sunset and it continues up to the point where the sun is 18 degrees below the horizon, and after that the night starts. So after 18 degrees, there is no light which we receive from the sun. It is totally dark. Now in the morning, the twilight commences when the sun is 18 degrees below our horizon. It reaches at a point when it is 18 degrees below our horizon. That is the period when the twilight starts. Right now, the laser pointer is showing that instant when the sun is 18 degrees below the horizon. We keep on receiving this twilight till sunrise, and as soon as the sun rises, the twilight ceases and we are able to see the sun and receive the sunlight. Now this entire period of 18 degrees is divided into 3 different stages, and we call these 3 different stages as civil twilight, nautical twilight, and astronomical twilight. Now let us see these 3 stages of twilight one by one. Now we have zoomed into the right side portion of the diagram depicting the sunrise. Now you see the sun is at this instant at a particular time. As the sun approaches towards our horizon, right now it is night, it is totally dark. We are not receiving any light from the sun. Now when the sun reaches at this particular point, you can follow the laser pointer on the screen. When the sun reaches at this particular point, now this point is 18 degrees below the horizon. You can see the angle also mentioned here. The sun has reached 18 degrees below the horizon. Now this is the instant when the astronomical twilight commences. The astronomical twilight has commenced at this particular instant. and we are able to receive some light, though very, very little at this particular point of time from the sun. After this instant, the sun keeps on coming closer to the horizon, and the altitude it was initially minus 18 degrees when the twilight started. Now it starts to come down, minus 17, minus 16, minus 15, and so on. Now at this particular instant, the sun is 12 degrees below the horizon. You can see this angle is 12 degrees now. It is marked in the diagram. Now this is the instant when the sun is 12 degrees below the horizon, and at this particular instant the nautical twilight commences. The nautical twilight has commenced here. After this instant, the sun keeps on coming closer to the horizon, and at this particular instant, you can follow the laser pointer. At this particular instant, the sun is 6 degrees below the horizon. The angle is shown in the diagram. And at this particular point, when the sun is 6 degrees below the horizon, civil twilight commences. Now, all these three twilights, they go up to the sunrise. Each of them, the astronomical twilight, nautical twilight, and civil twilight, lasts until the visible sunrise. Visible sunrise is when the sun's upper limb appears on our visible horizon. That's the instant we call as visible sunrise. So you see, the commencement time of all the three twilights are different. Astronomical twilight commences when the sun is 18 degrees below the horizon. Nautical twilight commences when the center of the sun is 12 degrees below the horizon. Civil twilight commences when the sun is 6 degrees below the horizon. And all three of them, they last until the visible sunrise, when the upper limb of the sun appears on our visible horizon. Now, out of this entire period, as far as navigators are concerned, as far as sight taking is concerned, which is the most suitable period for us? The most suitable period for us is between 12 degrees and 6 degrees. This particular period, which is represented in blue, the upper period is represented in light blue, and the bottommost period is represented in dark blue. The middle portion is what is important from the point of view of the navigator for the purpose of sight taking. Now this period is basically the commencement of nautical twilight to the commencement of civil twilight. The suitable period for us for sight taking starts at the commencement of nautical twilight in the morning, and it remains up to the commencement of the civil twilight in the morning. Now, why is this period suitable to us? If you go beyond this particular period into the dark blue zone, now in the dark blue zone, the sun is 18 degrees to 12 degrees below the horizon. With the sun more than 12 degrees below the horizon, there is very less light for the horizon to be clear to us. The horizon may not be very much clear to us because the light which we are receiving is very, very, very low. Now, as the sun reaches about 12 degrees below the horizon, we have sufficient light with which the horizon can be clearly seen. And we know for the purpose of sight taking, we need to have the horizon as well as the body in our sight. So we can start our sight taking at this instant when the sun is 12 degrees below the horizon. And this suitable period continues up to the sun going 6 degrees below the horizon. Now, when the sun reaches 6 degrees below the horizon, you see as it is coming closer to the horizon from 18 to 12 and from 12 to 6 now, more and more light is visible to us on the eastern horizon. Now at this particular instant, when it is just 6 degrees below our horizon, there is so much of light on the eastern horizon that stars and other celestial bodies, stars as well as the planet, they start to disappear. So after 6 degrees, we may not be able to easily identify, find out the stars for the purpose of sight taking. It is so bright in the sky that the stars start to disappear. So this period is also not very suitable for us for the purpose of sight taking. The most suitable period is commencement of nautical twilight when the sun is 12 degrees below the horizon to commencement of civil twilight when the sun is 6 degrees below the horizon. Beta, any doubts up to here, up to what we discussed?
सर ये जो बोला है ना इसको एक बार आप नॉर्मल वर्ड्स में समझा दो, मेरे वैसे समझ में आ जाएगा, मतलब इसमें थोड़ा कम समझ में आया। ये तो समझ में आ गया कि 18 डिग्री पे 12 से इसमें ये होता है, इतने पे ये और 6 डिग्री पे ये, लास्ट में जो बोला था वो।
ओके बेटा, दवाई देने से पहले बीमारी पकड़नी पड़ेगी। व्हाट इज द डाउट यू आर हैविंग?
नहीं सर, ये जो ट्वाइलाइट का बताया ना कि ये तो पता चल गया 18 डिग्री पे एस्ट्रोनॉमिकल, 12 पे 6 पे ये चालू हो जाता है नॉटिकल, और ये तो सारा ये तो पता है।
वेरी गुड।
हाँ, इसके बाद ट्वाइलाइट क्या होता है ये भी पता है, पर जो लास्ट में बोल रहे थे ना कि सन यहाँ पे नहीं दिखेगा ये वाला, ये थोड़ा सा बता।
सूटेबल पीरियड इज व्हाट यू आर हैविंग डाउट इन, राइट?
हाँ।
ओके, सुनो बेटा, ध्यान से सुनना। यू कैन म्यूट योर माइक नाउ। सो हमारी जो ट्वाइलाइट है ये 18 डिग्री बिलो द हॉराइजन पे शुरू हो गई है, बट एट दिस इंस्टेंट सन बीइंग 18 डिग्रीज अवे फ्रॉम आवर हॉराइजन, इतनी कम लाइट है कि हमें हॉराइजन दिख ही नहीं रही। साइट लेने के लिए हमें हॉराइजन भी क्लियरली दिखनी चाहिए और सेलेस्टियल बॉडी भी दिखनी चाहिए। 18 से 12 में हमें ये प्रॉब्लम आती है कि हॉराइजन क्लियरली नहीं दिख पाती है। जब सन 12 डिग्री पे पहुंच जाता है हॉराइजन दिखनी शुरू हो जाती है, एंड 12 to 6 वी कैन एंजॉय टेकिंग साइट्स। व्हेन द सन रीचेस 6 डिग्रीज बिलो द हॉराइजन, अब एक और दिक्कत आनी शुरू होती है। 6 डिग्रीज बिलो द हॉराइजन इतनी ज़्यादा लाइट दिखनी शुरू हो जाती है दैट स्टार्स एंड प्लैनेट डिसअपियर। सो व्हेन द सन इज विद इन 6 डिग्रीज ऑफ द हॉराइजन, इट इज़ नॉट अगेन पॉसिबल टू टेक द साइट। तो हमारा जो सूटेबल पीरियड है वो है 12 to 6, कमेंसमेंट ऑफ नॉटिकल टू कमेंसमेंट ऑफ सिविल। ओके,
मतलब 6 से 12 के बीच में जो साइट लेंगे दैट इज द बेस्ट। सिविल ट्वाइलाइट में लाइट बहुत ज़्यादा हो जाती है तो आएगी नहीं, एस्ट्रोनॉमिकल में अंधेरा बहुत ज़्यादा होता है, क्लियर नहीं होता तो नहीं आएगी। तो बेसिकली 12 और 6 के बीच में जो साइट लेते हैं दैट इज द बेस्ट टाइम टू टेक द साइट।
हाँ बेटा, अगर आपको अवेलेबल हो 12 से 18 के बीच में या 6 से 12 के बीच में तो आप ले सकते हो। आई एम जस्ट टेलिंग कि प्रैक्टिकली आपको 0 से 6 और 12 से 18 के पीरियड में जो लाइट ब्लू और डार्क ब्लू पोर्शन है इसमें साइट लेना मुश्किल होगा।
हाँ ठीक है।
ओके ओके बेटा, ग्रेट। और कोई डाउट बेटा? ओके, लेट्स प्रोसीड अहेड नाउ। हमने मॉर्निंग ट्वाइलाइट देख ली है, लेट्स गो इन द इवनिंग नाउ एंड सी व्हाट हैपेंस आफ्टर सनसेट। Now we have zoomed into the sunset part of the diagram. This is the instant when the sunset takes place. So in the evening, as soon as the sun sets, as soon as we have a visible sunset, which means the sun's upper limb has disappeared from our visible horizon, this is the instant when all the three twilights commence. So the commencement time in the evening for all the three twilights is the visible sunset. The civil twilight continues till the time the sun is 6 degrees below the horizon. At this particular instant, the sun has gone 6 degrees below the horizon. You can see it is represented in the diagram also. Sun is 6 degrees below the horizon, and this is the period when civil twilight ends. The other two continue. The sun goes further down, and when the sun reaches at this particular instant, when it is 12 degrees below the horizon. So sun is at 12 degrees below the horizon here. The nautical twilight ends. Astronomical twilight still continues. The sun also moves down, and when the sun reaches at this particular instant, when it is 18 degrees below the horizon, the astronomical twilight ends. So we can clearly see that all the three twilights begin at the time of visible sunset. Civil twilight continues till the sun is 6 degrees below the horizon. Nautical twilight continues till the time sun is 12 degrees below the horizon, and astronomical twilight continues till the time the sun is 18 degrees below the horizon. After 18 degrees, there is no light received from the sun, and we have total darkness or the night. Now, in this case also, the suitable period for us for the purpose of sight taking is between 6 degrees and 12 degrees, which in this case is the ending of the civil twilight to the ending of the nautical twilight. This is the most suitable period for us. Before this period, the sun is within 0 to 6 degrees of the horizon, and there is too much light for the stars and planet to be visible to us. There is so much light that stars and planet may not be visible. Between 6 to 12 degrees, the light has decreased now. The stars and planets start to appear in the sky. They gain sufficient brightness so that we can observe them by the sextant for the purpose of sight taking. And after this interval, that means when the sun has gone below the horizon more than 12 degrees, there is so less light available from the sun that the horizon is not clear to us. The stars and planets are shining very bright, but the horizon being not visible, it will not be possible to take the sight. So again, the light blue portion is not suitable because there is too much light. The dark blue portion is not suitable because there is too less light for the horizon to be visible. The suitable period for us is the middle period, the blue color period, which is represented by minus 6 degrees to minus 12 degrees altitude of the sun. This is the most suitable period in the case of evening twilight. Now, be careful and be clear in your mind that in the morning, the suitable period was commencement of nautical to commencement of civil, whereas in the evening, the suitable period is ending of civil to ending of nautical. Now, practically, if you are trying to take a star sight, you need to be standby on the bridge wing ready with a sextant at this particular instant. That is when the sun is 6 degrees below the horizon. This is the instant when we are ready with the sextant on the bridge wing for the purpose of taking the sight, because this is the beginning of the suitable period for us. If we are ready here, we can observe the horizon also, we can observe the celestial body also, and a sight can be taken. If you are standby at this particular instant, that is ending of the nautical twilight, it will not be of use because the horizon is going to disappear now. So we need to be standby. This is the critical time as far as the evening twilight is concerned. That is the ending of civil twilight. Now, in the case of morning, the beginning of the suitable period is when the nautical twilight commences. Because in the morning, when the sun is coming from below the horizon, it reaches 12 degrees below the horizon. That is where the nautical twilight commences. At that time, the stars are visible in the sky, the horizon also starts to appear, and a sight is possible. So the beginning of the suitable period in the morning is commencement of the nautical twilight, and the beginning of the suitable period in the evening is the ending of the civil twilight. Any doubts up to here, beta? Okay, great. Let's proceed ahead then. Now with this, we finish understanding the concept of number 1, stellar magnitude. Then the information given in page 268 of the almanac, the stars information table, and the concept of twilight. With all these three clear in our mind, we can now go into the questions related to stars suitable for observations. Now, these questions are divided into different types. This is how they can be asked to us in the examination. We have broken them up into different types, and we will be discussing these types one by one. The type 1 question which comes in the exam, the most basic and the most simplest question related to this topic is that they will ask you which stars will be within a certain R angle of the observer's meridian at a particular given time. So we are now going to see how do we solve this type 1 problem. Okay, now beta, for this I will take you to a video where we will have some practice questions. This type 1 will be the first question which we practice. How to find the stars within a certain R angle of the observer's meridian. So it's almost time for a break now. So let's go ahead with our break, and once you come back, we are going to see these different types of questions. So any doubts in the mind?
No, sir.
No, sir.
Okay, great. See you after the break then.
Thank you, sir.
Thank you.